Welcome to the lecture number 63, dear students. Circle, we have already started this 3.4. We have begun it in the last lecture. So you will find here, now I am going to do the sum number 2. Now in sum number 2, you will find quadrilateral PQRS is a cyclic quadrant, correct? And in addition to that, PQ is congruent to QR. That is what is given. Angle PSR is also given. PSR, this angle is given as 110. So we have to find out all these things. Okay. So let's begin from the first one. That find out angle PQR. Now to get angle PQR, we have studied this theorem in detail, that opposite angles of cyclic quadrilateral are always supplementary. So therefore 110 plus 70 will give you 180. But how to write it? Please see here. So I have written over here PSR, this PSR plus angle PQR is equal to 180. Opposite angles of cyclic quadrilateral. But value of PSR is given as 110. Value of PSR is given as 110. So 110 plus angle PQR is equal to 180. Now transfer this 110 to the right hand side. Here to the left hand side it is plus. So it is going to become minus. So you will get PQR is equal to 180 degree minus 110 is equal to 70 degree. So this is how our first answer is 70 degree. Clear? Now second question is measure our PQR. Please see here. Measure our PQR. Now this is 110. What type of angle PSR is there? Inscribed angle. Why it is inscribed angle? Its vertex is lying on the circle and therefore it has intersected R PQ. Correct? So you will find half angle. So angle PSR is equal to half measure R PQR. Measure of inscribed angle is always equal to half the intersected R. Intersected R is always R which is facing the angle. So you will find value of PSR is given 110. If I transfer this 2 to the left hand side, I will get 110 into 2, that is 220. So therefore measure R PQR is 220. So this whole R is how much? 220. But you will notice very important. PQ is congruent with QR. PQ is congruent with QR. And if chords are congruent, please try to understand. If chords are congruent, corresponding arcs are also congruent. What is the measure of total PQR? Total PQR is 220. If it is equally divided into two parts, then we will get measure R PQ is 110 as well as measure R QR is also 110, and that is what you will find here. So measure R QR is equal to measure R PQ, congruent arcs of congruent chords, and therefore measure R QR is equal to half the measure R PQR, but PQR is 220. So you will find here half into 220 is how much? 110. So this is how you will find R PQ as well as R QR are 110 each. Clear? Now next one. Next question is also very important. Find out angle PRQ. Now where is vertex of angle PRQ? Is on the circle. If it is on the circle, naturally it is an inscribed angle, and measure of inscribed angle is always equal to the half the intersected R. Now what is measure of PQ? PQ is 110. Half of 110 is how much? 55. So we will be getting PRQ is 55. So you'll find your measure angle PRQ is equal to half measure RP, that is half into 110, that is equal to 55. So please try to understand. If PSR is 110, PQR is 220. Next to that, S plus Q is equal to 180. Opposite angles of cyclic quadrilateral, if this is 110, this is going to be a 70. Total R PQR is twice of this angle, because this angle is half of R PQR. So that is equal to 220. But 220, if we divide into two component parts, we'll be getting 110. This is also 110. Angle PRQ is also instead angle, that is equal to half R PQ, and hence it is equal to 50. That's all for this sum. Please have a look at this sum here. Now question number 3. Question number 2. In which cyclic quadrilateral MRP is? Quadrilateral MRPN is cyclic quadrilateral. Okay, so first of all, I'm going to draw figure. This is question number 3. So you will find here students. Quadrilateral MRPN is a cyclic. Let's draw the figure of MRP. MRPN. MRPN is a cyclic quadrilateral. The next to that it is given angle R is 5x minus 13 given angle R is equal to 5x minus 13. So 5x minus 13. In addition to that, it is given n is equal to 4x plus 4. 4x plus 4. Angle n is equal to 4x plus 4. Question asked is, find the measure of R and n. Very simple. Find angle R and angle N. Okay. In degrees, of course, we have to find out their measures in degrees as well as in integral, because at present what is there? They are in terms of variables. Okay, let's begin. Answer: quadrilateral MRPN is cyclic. Cyclic is very simple concept that all vertices are lying on a circle. Therefore, angle R plus angle N is equal to 180. Opposite angles of cyclic quadrilateral. Opposite angles of cyclic quadrilateral MRPN. These are opposite angles of cyclic quadrilateral, and opposite angles of cyclic quadrilateral are always supplementary. Now I am going to substitute value. R is 5x minus 13. Okay, so 5x minus 13 plus 4x plus 4. 4x plus 4. That is equal to 108. Now I am going to find out value of x by solving this equation. Very simple. 5x plus 4x is 9x minus 9. Because minus 13 plus 4. That is equal to 180. That is equal to. So 9x is equal to 180 plus 9. If I transfer this 9 on the right hand side, it will become this. So 9x is equal to 189. 180 plus 9. So x is equal to 189 upon 9. So x is equal to 21. Very simple. Do we have to find out value of x? Question is not to find out value of x. Question is to find out value of angle R as well as N. But angle R and angle N are given in terms of variable x. So angle R is equal to 5x minus 13. That is equal to 5 into 21 minus 30. 21 5 is 105 minus 30. That is equal to 92. This is how you will be getting angle R. 5x minus 30, 5 into 21, 105. So that is equal to 92. Angle N is equal to 4x plus 4. That is 4 into, since we know the value of x now, that is 21. Angle N is equal to 88. Please have a review of this sum quickly. So you will find that quadrilateral MRPN is given as cyclic quadrilateral. Value of R is given as 5x minus 13. Value of N is given as 4x plus 4. Question asked is find out the value of R as well as N. So you will find here MRPN is cyclic. MRPN is cyclic. So angle R plus angle N. Angle R plus angle N are supplementary angles, opposite angles of cyclic quadrilateral MRPN. So R is 5x minus 30 plus N, that is 4x plus 4. 5x plus 4x is 9x minus 30 plus 4 is minus 9. If I transfer this on right hand side, 9x is equal to 180 plus 9. 9x is equal to 189. X is equal to 189 upon 9. 9 2s are 9 1s are, x is equal to 21. R is equal to 5x minus 30. 21 505 minus 30 will give us 92. N is equal equal to 4x plus 4. 21 4 is 84 plus 4 is 88. So very simple sum. We have to use the property that opposite angles of cyclic quadrilateral are supplement. Please have a look at this sum. Question number 4 now. Exercise 3.4, question number 4. For question number 4, figure is given. So you draw figures. In this circle, we will find RS is given as a diameter. Diameter always passes through the center. So you will find RS is a diameter. Here there is point O. Now, question is given that T is any point. T is any point over here. T is any point outside the circle. T is any point given. Point T is in the exterior of the circle. And we have to prove that, okay, in given one more thing will come, RS is a diameter. Since diameter passes through center. To prove that, angle RES is less than 90. Angle RES is an acute angle. Okay, now we have to join this RES to get that angle RES. If I take point M over here, okay, we have to prove this is an acute angle. Very important property is that. Okay, let's begin the proof. Very important property that angle subtended by diameter. Subtend means what? RS is a segment. That segment has formed that angle RMS. Angle subtended by diameter is 90. Why it is 90? Very simple reason. This angle M is inscribed angle. Why it is inscribed angle? It is lying on R of a circle. And you will find if it is lying on R, then this angle is inscribed angle which has intersected this R. This RS is a semicircle. Is a semicircle because its RS is a diameter. And if it is a semicircle, you will find then this measure of our RS is how much? 180. Half of 180 will give us 90. Half of 180 will give us 90. Therefore, angle subtended by diameter is always 90. Okay, that is what I am going to write now. So, find, improve angle RMS is equal to 90. Straight away you can write angle subtended by diameter. Angle subtended by diameter. In addition to that, if you like to write, then you may write this way: angle RMS is equal to half measure RS. Okay. No need to write all these things, but since for your convenience I am writing. Fine. So you will find here RMS is equal to 90. Now please try to understand. For triangle TMS, I am talking about this triangle TMS. This is 90. So for triangle TMS, for triangle TMS, for triangle TMS, angle RMS, angle RMS is an exterior angle. Is an exterior angle. Very, very important property. That for triangle TMS, angle RMS is an exterior angle. And exterior angle is always greater than remote interior angle. Since remote interior angle, so I will write it differently. Since remote interior angles are smaller than exterior angles, since remote interior angles are smaller than exterior angles, therefore angle RPS is smaller. This is sign smaller than angle RMS. But measure of RMS is how much? 90. So RPS is less than 90. Therefore, angle RPS is an acute angle. Very simple. Is an acute angle. Okay, let's have a review of this sum quickly. Now you will find, dear students, this is a circle given in which RS is diameter and angle subtended by diameter is always 90. So angle RMS is 90. Why it is 90? Because you will find it's an inscribed triangle. Measure of that is equal to half on RS. But RS is a semicircle because RS is a diameter and therefore half on 180 will give us 90. So you will be getting RMS as 90. These are angles in a linear pair. Anyway, next to that, for triangle TMS, for this triangle, this is an exterior angle. Exterior angle is angle which forms a linear pair with the angle of triangle. Okay. So therefore, this is exterior angle, and exterior angle is greater than remote interior angles. exterior angle is greater than remote interior angles, or we can say the same things, that exterior angle is greater than remote interior angles, or remote interior angles are smaller than exterior angles. Therefore, you will find angle RTS. To say MTS or to say RTS is one and the same. So you will find RTS is smaller than RMS. The RMS is 90. So RTS is less than 90. So if it is less than 90, it's an acute angle. See, please look at this carefully. Question number 5 will do now. Exercise 3.4. Question number 5 I am going to do now. All these are that are small questions, not very big questions as such. Weightage is always 3 or 2 marks. Question number 5. Prove that any rectangle is a cyclic equilateral. Prove that. Any rectangle is cyclic quadrilateral. So given, I am going to draw figure. Quadrilateral ABC is a rectangle. Then to prove that quadrilateral ABC is cyclic. So you find here, if I draw a very simple figure. ABC, since it's a rectangle, what its angle of 90 degree. Very simple sum, nothing to explain. Proof. Angle A plus angle C is equal to 90 plus 90, that is equal to 180. Angle B plus angle D, B plus D is also 90 plus 90, that is equal to 1. Since opposite angles of quadrilateral ABC are supplementary. Therefore, quadrilateral ABC is cyclic. Very simple. Quadrilateral is given as rectangle, and you all know A, B, C, D, all angles are of 90 degree. A plus C is 180 as well as B plus D is 180. Nothing to understand here. Quadrilateral ABCD. To prove that ABCD is a cyclic, it's a rectangle. A plus C, 90 plus 90, 180. B plus D, 90 plus 90 is 180. Since opposite angles of quadrilateral ABCD are supplementary, quadrilateral ABCD is a cyclic. Very simple sum. So please look at this sum carefully. Okay, dear students. Now I am going to do solve question number 6. Very simple. These all sums are very simple. Simply we have to use the property. We have to use the property. Question number 6 now. Question number 6. Figure is given there. Triangle WXY. This is the triangle WXY. WXY is a triangle, and we will find from points y and x, from points y and x, YZ is drawn perpendicular, and from point x, xt is drawn perpendicular. X is okay. Here point of intersection is P. And question asked is to prove that WZPT is cyclic. To prove that, two reasons we have to prove. WZPT quadrilateral is cyclic, and second one is points x, z, t, y. Points x, z, t, y are concyclic. Okay, proof you see here. You have to recall one theorem that we have studied, very important theorem we have studied. That you have to understand. First part is very easy. First part, WZPT, in which Z and T are opposite angles. Z and T are opposite angles. And if opposite angles are supplementary, then quadrilateral is cyclic. Okay, very simple. Z and T are opposite angles. So I'll write here in quadrilateral WZPT. In quadrilateral WZPT, angle Z plus angle T is equal to 90 plus 90. So angle Z plus angle T, that is equal to 180. Angle Z plus angle T, Z plus T are 90 each. Reason is XT is perpendicular to W1, XT, W1. Likewise, you will find YZ. 1Z is perpendicular to WX. Reasons also are given. So Z plus T is equal to 90 plus 90. That is equal to 180. Since opposite angles of quadrilateral, WZPT are supplementary. Quadrilateral WZ is cyclic. If opposite angles are supplementary, it's cyclic. Okay, second part. Points X, Z, T, Y are concyclic. Concyclic means what? Line on the same circle. Okay. So answer of 2. See, we have studied this theorem. We must write all statements over here. Points X and Y. Points X and Y subtends congruent angles that is angle Z is equal to angle T, that is equal to 90 on the same side of segment XY. Therefore points X, Y, T, Z, X, Y, T, Z, X, Y, T, Z are concyclic. We have studied these theorems, students, and explained this theorem. It's very, very important. Simply I have drawn the figure and I explain it. So you will find that XY is any segment and X and Y have subtended angle Z as well as angle T. Each one of them are 90 each. They are congruent, and as they are congruent, very important, as they are congruent, you will find, so points are concyclic. First part is very easy. WZPT is a cyclic quadrilateral, reason being that opposite angles X plus T are 90. But second part is important to understand. X and Y subtend angles Z and T on the same side. Please excuse me. On the same side of XY, which are also congruent. Because this is 90, this is also 90. And therefore you will find that X, Z, T, Y are concyclic points. Please have a look at this sum carefully. Okay, now let's do the question number 7. Question number 7. Circle is given. Circle is given. Please have a look here. Figure is there. Page number, I'll tell you the page. Page number is 74. Page 74. Then you will find figure is given in which point N is lying outside the circle. Point N is lying outside the circle. Here you will find point N, S, NS is there. Two arcs are there, EF, as well as NS. Fine. So, question is measure arc NS given. Measure arc NS is given as 125 and measure arc EF. Measure arc EF is given as, that is equal to 37. Question is find angle NMS. See students, in my lecture number, I think so, 62, before that 61. In my lecture number 61, I have given a very important, so many figures I draw, and I also explained you the measures of the angles on the basis of the position of their vertices. So you have to revise that, otherwise you will not understand this. So in this case, if vertex of the angle is in the exterior of the circle, so angle NMS is equal to half measure arc, because two arcs are intersected by this angle NMS. Two sides are there. One is NN and other one is NS. So which arcs are intersected? NS as well as EF. So half measure arc NS minus measure arc EF. I have given you this. I am repeating the same thing, but I have given you different positions of the vertex of the angles and the measures of this. So simply in the second step, I substitute the values. NMS is equal to measure arc NS minus measure arc EF, that is 125 minus 37. Vertex of the angle. For your reference, I am writing in the exterior of the circle. In the exterior of the circle. So 125 minus 37 upon 2, that is equal to 1 upon 2 into very simple. So you have to understand this theory, nothing else. Question is very simple. But if you know the fact that whenever vertex lies in the exterior of the circle, then measure of the angle is half the difference between the arc intersected by that angle. Two arcs are intersected. One is NS, other one is EF. So difference between them is, surely you will find that 125 minus 37 is 88. Half of that is 44. Very simple. Please have a look at this. Okay, now I'm going to do the last sum of this exercise 3.4, so that next time we are going to study a very important theorem that is called as tangent secant theorem. Tangent secant theorem. It's a difficult theorem, very rarely asked in the examination because of its difficulty level. But if it is asked, we should be ready to write the proof, which is really a challenging one. So for this last question, two chords are given which are intersecting each other in the interior of the circle. Fine. It is given. Given is measure R. A is 95. A is 95. And measure R. Second R is given. That measure R. Sorry. Yes, measure R. Angle given. Okay, fine. Measure angle. Measure angle. ABE is given as 108 degree. Question asked is find measure RDC. Please excuse me for extending this lecture a little bit. Reason being that next time I have to begin the important big theorem. Okay, now try to understand the position of the angle. Okay, what is given? Angle AB. What is given? Angle AB. What is the position of the angle ABE, vertex of angle ABE in the interior of the circle? Very important to understand these things. If vertex position is in the interior, then how to find out measure of that angle? When vertex is on the circle, how to find out measure of this? So vertex is outside the circle, how to find out its measure? Very, very important things. Okay. So measure angle, measure angle ABE is equal to ABE is equal to half the measure R AE plus RDC. AE plus measure R DC. Very important. Whenever vertex is in the interior of the circle, then half the sum of the R intersected by the angle as well as R intersected by its vertically opposite angle. Very important. Very important. So that is equal to half. Okay. The next step is equal to half. Fine. Measure R A. Value of measure R A is given as 95. So 95 plus measure R BC. That is equal to ABE is 108. 108. Vertex of the angle in the extreme, in the interior of circle. So 108 into 2, that is equal to 95 plus measure R. Very simple. Mathematics I transfer 2 to the left hand side. 108 into 2, that is 216 minus 95. That is equal to major arc DC. So 121 is equal to major arc DC. Simple, but you must know the fact that when vertex is in the interior, anywhere in the interior, not at the center, that is equal to half the sum of the arcs intersected by the angle and its vertically opposite angles. So major arc A is 95, AB is 108, major arc BC. AB is equal to half major arc A intersected by angle plus major arc BC intersected by its vertically opposite angles. Value of this is given half 95, value of A plus major arc BC. 260 minus 95 is equal to this. 121. Thanks a lot. Thank you very much for listening this all lecture number 63 carefully. Try to understand these concepts, but to understand these concepts, very important is revision. Right? If you would have revised it nicely, that what are the positions of the vertices of the angles and accordingly how to find out their measures, surely these sums are easy. Otherwise, you will not understand. Thanks a lot. Thank you very much. God bless you all. I'm going to conclude my lecture number 63. Thanks again.